first time to present a paper in this form, but I still hope my presentation could reach you well. So I will introduce our paper on the optimal strategies and market equilibrium in a multi-resource internet access market. So first, what is an internet access market and why do we consider that? As we may all notice, the popularity of content delivery services has been rapidly increasing nowadays. And these top players like Netflix and YouTube, they have accounted a huge portion of internet traffic. Because they compete with each other to attract more users, the quality of service should be among their primary concerns. Intuitively, long loading time and low visible resolution mean less willingness of users to watch their videos. So they will desire for low traffic delay and high overall throughput, which mean better service quality. And the quality of service deteriorates due to network congestion and bottleneck links. So these content providers have incentives to pay for some additional resources that could address the issues. So two common examples. First is premium peering, which is a dedicated bandwidth capacity at the peering link, so the congestion could be relieved. For example, Netflix has negotiated with Comcast and Verizon for such an agreement. Another example is cache. So if a cache is distributed near users, then long distance transmission could be avoided and traffic delay could be effectively reduced. So also the example of Netflix, it has its own distributed cache system called a cache. So now that we know acquiring either bandwidth or cache resource will improve the quality of service, and then what about deploying a hybrid of these two resources? So not only these two, but we consider a more general concept of access resources, which could also include other types such as user peers in P2P networks. So we consider a scenario that these resources are available for purchasing from the last mile internet service provider. And CPs could purchase these resources to improve the quality of service. Then, from the perspective of a CP, it would like to know how much of each type of resource it should procure, so it could optimize its own utility, which is the revenue minus the payment. And on the other hand, there are also other participants in the market. They have their own goals. For example, an unregulated ISP would like to maximize its own revenue, so it would like to sell as much capacity as possible. But regulators may concern about the total revenue that could be generated, which is defined as the social welfare. So the problem we consider is an internet access market where CPs could determine their purchasing strategies on different types of access resources. And we want to study a so-called market equilibrium, which would be defined later. And to study the equilibrium, we also propose and study a detailed content delivery model first. And followed by that, we also have some observation and evaluation of the results. Generally speaking, these content providers may consider purchasing a hybrid of access resources to better improve their quality of service. So this is the scenario that we consider. There is one last mile access provider, which is the ISP, and multiple CPs that could purchase. Here we consider two types of resources first, premium peering and caching, as we just mentioned. They together serve a region of end users. So the combination of these two types of resources could better improve the quality of service. And the ISP specifies the prices, which are denoted as PB and PC, respectively. The content provider, I, determines its own purchasing strategy, which is the units of capacity of both resources, XIB and XIC, then the payment to ISP is intuitively PBXIB plus BCXIC. So as we just mentioned, an individual CP may focus on what is the optimal strategy to maximize its own utility. The utility is defined as the revenue minus the payment, and here we first define the revenue. Because content providers provide contents to make revenue, we know that the revenue generally increases when users request for more contents and generate more traffic. So we define it as the average per unit traffic revenue times the aggregate throughput. And aggregate throughput is defined as a function of the purchasing strategy xi because it determines the QS that could be achieved, which directly affects the user's desire for contents. On the other hand, the social welfare is defined as the total revenue that could be generated, so it is the aggregate revenue of all CPs. So let's talk about content delivery. We say that less congestion and better QS are indeed two sides of the same coin. The congestion level of a route could be described by the average traffic delay. And from last page, you will know that the quality of service is related to the aggregate throughput. So given congestion level, the route could accommodate certain throughput, and larger throughput also influences the congestion level because delay is longer. And because they mutually impact each other, we propose a concept of desirable throughput, and later we will see the relationship between this desirable throughput and the actual throughput. So the desirable throughput captures users' desire for content. As we know, if the quality of service is better and the congestion level is lower, there will be more users willing to use the service of a content provider. And each of these users would generally desire more contents from this CP. So we define it as the user population times the proportion of users who actively use the CP times the desirable throughput of each active user. So as a result, we also have this per user desirable throughput, lambda I di. And here is the mutual impact I just mentioned. If user's desire is not fulfilled, the CP tends to increase the throughput, which causes more severe congestion, and the delay is higher, then the desirable throughput is restrained. Users' desire would be lower, so as a result of such mutual impact, the content delivery tends to reach such a steady state where the actual throughput is exactly the aggregate desirable throughput. And from our definition, the desirable throughput is also dependent on the actual throughput phi I, because the delay is related to it. And we provide some detailed analysis, and we show that given the purchasing strategies of a CP, the steady state throughput is actually unique. So we call it a function of the purchasing strategies xi. And more detailed discussion and analysis of this content delivery model could be found in our paper. Now we talk about the market equilibrium. So the ISP has limited supply of resources, and CPs would correspond to varying prices set by the ISP with their demand. And there is another mutual impact here. If the price is quite low, then there will be unfulfilled demand. Then if the price is overly high, there will be underutilized resources. So the market tends to reach an equilibrium at which supply and demand are balanced. So the market equilibrium is defined as a pair of price and demand, if and only if the demand matrix clears all the available supply, and the price P is referred to as the market clearing prices. And we want to focus on the optimality of such an equilibrium. So the ISP could adjust the prices to balance the supply and demand. And meanwhile, there are different maximization goals of the market participants. So we want to know whether they could be achieved simultaneously. As we mentioned before, from the perspective of the entire market, it would like to maximize the social welfare, but each CPI would like to maximize its own individual utility. And our conclusion, the most important conclusion here, tells us that if the throughput satisfies certain monotonicity and concavity conditions, there is such a market equilibrium where the utility of each CP is maximized, the social welfare is also maximized, the market clearing prices is unique, and the market equilibrium demand is also unique. And you may say this is only for two types of resources. So we also generalize it to a more general multi-resource market. So if there are L types of resources, and we define the supply, the price, the purchasing strategies accordingly, and if the conditions are similar, the same result still exists. And at this market equilibrium, various objectives of different market participants could be achieved simultaneously. CPs could maximize the individual utilities, ISP could fully utilize the supply of resources, and regulators could also maximize the social welfare. So it would be welcomed by the entire market. And we also study some characteristics of the market equilibrium. We have the relationships among the demand and sensitivity analysis. So that is the theoretical result. So we also have some numerical evaluation to show that how the market equilibrium respond to various parameters in the market. So we go back to the two resource market and we study three top CPs who generate the majority of traffic. And each time we vary one parameter while others remain their baseline values, and we could observe the dynamics of the market equilibrium. For example, if the per unit traffic revenue of CP1 is increasing, we can see how the optimal hearing bandwidth of each CP corresponds. So intuitively, CP1 would generally acquire more and the other two would acquire less. And it would also cause the prices to increase. And also, there is some correlation between the two purchasing strategies, and the optimal cash capacity also has a similar trend. And intuitively, CP1 could generate more revenue and more utility, while the other two get less. So similarly here, if we vary the cash capacity, how would the optimal strategies, the prices, the revenues, and the utility respond? And we could learn that some deeper understanding from the numerical evaluation on how to choose the resource prices or purchasing strategies. And our study provides some insights on the optimal response of CPs to a dynamically changing market, so they could still reach the market equilibrium. So that's all of my presentation, and Thank you.